In this series of videos, we're going to see a bunch of examples, probably more than any other of the series in this course. We have to set things up though. Let's recall the chain rule for differentiation. It says that if we're differentiating with respect to x, a composition of functions, so I'll say f of u of x, then the result is f prime of u of x times u prime of x, right? And the chain rule is the thing that says, hey, the derivative of the inside function is going to appear as a factor of the result. So, for instance, if we're looking at y is equal to the sine of x squared, then y prime is going to differentiate the sine function. So I have the cosine of x squared. And then the chain rule is going to say, and then I'm going to multiply that result by 2x, the derivative of the inside function. We've seen how integration is the inverse of differentiation. So if I need to integrate, and I'm going to make this an indefinite integral, 2x times the cosine of x squared dx, I know the answer is going to be the sine of x squared, plus, of course, our constant of integration. This reversal of the chain rule is what we're going to call the substitution rule. And the way the substitution rule works is, if I identify a composition of functions in an integrand, then I look at the inside function, and I'm going to call that u. So I'm going to say u is equal to x squared. Now I'm going to differentiate both sides. And if I'm using correct mathematical notation, then I'm going to say that du is equal to 2x dx. I need differentials on both sides. Please, please, please include differentials on both sides. Here's where the substitution comes into play. 2x dx. The whole thing together gets replaced by du. And x squared gets replaced by u. Right? So that's the substitution. Our original integrand was the cosine. And so what I've done is I've substituted out the x's, and now everything is in terms of u's. That's the substitution of the substitution rule. The integral of the cosine is the sine, so I have sine of u plus c. But now we need to bring back, we had everything in terms of x. Now I have sine of u, right? So I need to bring it back in terms of x. But remember, u was a replacement for x squared. And so where I see a u here, I'm going to write down x squared. And that's how we end up with the sine of x squared plus c. So that's how the substitution rule works. When I see a composition, I identify the inside function as my substitution. And then I should have another factor running around if this is going to work. And that other factor is going to be related to du. It may not always be du directly, and we'll see how that works. To formalize this, we'll look at the substitution rule. It says that if u is g of x, a differentiable function whose range is an interval I and f is continuous on I, then the composition, the integral of the composition f of g of x times g prime of x dx can be replaced by the integral of f of u du. It's really key that I have g prime of x, really dx. In the case of something similar to the previous example, if I have the integral of the cosine of x squared dx, we're stuck. We can't integrate this because I have this composition and my x squared is here. I don't have a 2x over here for the dx. So we actually don't have an antiderivative for this. At least not one that we call a basic function, which are the functions that you're used to. Well, let's see the first of our many examples. We have here the integral, the indefinite integral, right? So I'll stop saying all that for a bit. the integral of x squared times the sine of x cubed dx. And we can see that we have a composition here. So I'm going to identify as the inside function u is equal to x cubed, which then if I differentiate means that du is equal to 3x squared dx. Please don't forget the dx. All right. Now here's the thing. I have the x squared here, but I don't have the 3. And that's okay. We actually can fix a constant. So I'm going to rewrite this. I just the integral of x squared times the sine of x cubed dx. And I'd really like to have a 3 in front of that x squared. So, hey, can I just write a 3? Sure. What I've done is I've multiplied by 3. It's all good if I multiply by 3 as long as I divide by 3. I can do this with constants. I cannot multiply by x and divide by x because this x is inside of an integral, this x is outside of an integral. These are not the same x's, if you will. But constants pass through integrals, right? I could pull out this 3 if I wanted. So now I've made it so that I have what I'll call a du inside of the integrand, right? And sometimes I follow through with the actual substitution and sometimes I don't. But for right now, we're going to go ahead and follow through with the actual substitution. And this 3x squared dx gets replaced by du. I have the sine of x cubed, but x cubed gets replaced by u. And of course that 1/3 comes out in front. So then what happens to the 3x squared? Well, it's in the du, or the 3x squared dx, right? Is in the du. Now I'm going to integrate the sine function. I'm going to write down something that I know is incorrect right now. So it's 1/3 times the cosine of u plus c. And this is incorrect. And I know this because the derivative with respect to x of the cosine of x is equal to the negative sine of x. And so if I were to differentiate this cosine of u, I would end up with negative sine of u. I don't have a negative here, which means my answer must be negative. I highly recommend whenever you are anti-differentiating a sine or cosine, after you write down the answer, double check and see if I should throw in a negative, right? So earlier we integrated the cosine and we got the sine. If I were to differentiate the sine function, I have a positive cosine. So that was all good. If you can remember that, really, that the derivative of the sine function is the cosine function, and then the cosine is the negative, then when you anti-differentiate, you'll have that negative straightened out. Well, this is in terms of u. I should have it in terms of x. And so the substitution was u equals x cubed. And so here, we're going to say the answer is negative 1/3 times the cosine of x cubed plus c. I encourage you to go ahead and differentiate this to check and see that you get the same result as what we have in the integrand.